Okay, we're going to continue working these time value money problems. We've answered problems 1 through 8 in previous videos. We're now going to answer problems 9 and 10 in this particular video, and we're going to learn some stuff. So in problem 9, we're going to start working on taking present values. Okay, so if you understand future values are easier to understand because we're looking at what retirement accounts are going to be worth in the future. Present values are a little more difficult, but it's a super important principle, particularly in corporate finance. And so let's go through problem number 9 and see if we can answer this question and gain a little bit of understanding. Suppose a company is contemplating investing in a project that would pay out $150,000 3 years from today. The company would finance the cost of this investment with equity. The company's return on equity from the balance sheet and income statement has remained steady at 12.5%. What is the most the company should pay for this investment? Okay. So if you understand what's happening, the company is investing some money today, and then in 3 years from today, that money is going to grow to be something $150,000 in 3 years. And so what we're going to do is we're going to discount this money back. So in the future, we're receiving $150,000 3 years from today. We're going to discount this money back at a rate of 12% to find the present value. Now, the question asks, uh, what is the most the company should pay for this investment? That present value is going to be super important in suggesting to the company that the company should not pay a penny over uh, what the present value of that future cash flow is going to be. Okay, so let's go ahead and do this. We're going to solve here in this particular problem for present value. We're going to receive $150,000 3 years in the future. So $150,000 is future value. 3 years from now is n, so 3 is n, and we're going to discount that future value back to today at a rate of 12%. Okay, so I'm going to type in $150,000, enter that into the future value function, zero payment. I'm solving for present value here. 12% is my I over Y, my rate of return, my interest rate. I'm going to discount this $150,000 back 3 years. Compute present value. Okay? And notice the present value comes back with a negative sign. That's expected. The future value of $150,000 was an inflow, so we treated that as a positive number. This present value is going to be an outflow, so it comes back with this negative number. It's $106,767. So this suggests that $150,000 3 years from today is worth $106,000 discounted back by 12% in today's dollars. Okay. To solve that in Excel, I say equals present value. It asks for the rate 0.12. The number of periods is 3. Payment is 0. Future value is a positive $150,000. Compounding at the end of the period. I'll let that sit for a second before I close my parentheses there. I hit enter. Excel shows it as a negative number. That's the parentheses with the red uh, color there that shows a negative 106,767. Okay, so that problem is going to be incredibly important for anybody that works in corporate finance. So we've uh, in corporate finance, there are going to be problems where a company is looking to invest in, say, like a marketing campaign, and it's going to cost the company, $100 million to invest in this marketing campaign, and it's going to produce cash flows of $40 million in each of the next 3 years. The question is should the company make that investment? It's important to understand how to discount those future cash flows back to today's dollars to compare it with the cost of the project that has been specified in today's dollars. Okay, so problem number 9 is actually a really important problem. Hopefully you understand that. Let's go to problem number 10. This is more of just a problem that I thought of that is just going to be confusing. Okay, but it helps us understand time value of money. So suppose you're receiving a gift of $1,000 today and $3,000 1 year from today. You want to start a certificate of deposit. It's like a savings account at Wells Fargo that pays 5% interest per year for 5 years. However, you're only able to open up one account but allowed to make multiple deposits into this CD. If you invest $1,000 today and the other $3,000 1 year from today, how much will you have at the end of 10 or at the end of 5 years? Okay? So we can do this one of two ways. I'm going to open up another sheet. So if this is years, I'm going to have 5 years, and this is the balance. Okay, actually, let me insert a row here. And year 0 is going to be today. Okay, so if we were to invest $1,000 today, the balance is going to be $1,000. All right, and it's going to earn 5% per year for 5 years. And in 1 year, so watch what happens. In 1 year, we're going to earn 5%. So I'm going to take $1,000 and I'm going to multiply that by 1.05. That is, I take the $1,000, I multiply it by the interest rate, which is 5%, and add it back to the 5,000, back to the initial amount of money, back to the $1,000. Okay, so that's going to be how much the balance is on the initial $1,000 deposit. Okay, and you could almost do that in your head, by the way. But then what I'm going to do is I'm going to add another $3,000. Right? Because it says if you invest the $1,000 today, that's going to grow at 5% for 1 year, and then you invest the other $3,000 1 year from today, how much will you have at the end of 5 years? So when I hit enter here, this is going to tell me what the balance is going to be. That balance is going to be $1,000 times 1.05, which is equal to $1,050, plus the $3,000 second investment that I'm making. In year 2, I'm going to say year 2 is just going to be that $4,050 multiplied by 1 plus R. Again, I'm taking the previous amount, I'm multiplying it by the interest rate of 5%, and I'm adding back in the previous amount. You see that? So this is what the account will be worth in year 2. In year 3, previous amount times 1.05. In year 4, previous amount times 1.05, and in year 5, previous amount times 1.05. So this account will be worth $4,922 and some change. Okay. So this is the long way. I think solving problem 10 this way helps us understand somewhat of the time value of money. But we can do this in another way. What we can do is we can treat this as 2 separate problems. All right. So the first problem is how much will the $1,000 be worth 1 year from today? And then the second problem is we're going to add 3,000 and then do a second future value calculation to account for the remaining 4 years. All right. So let's do this. So the first step, what I'm going to do is I'm going to find the future value at a rate of 5%, 0.05 in decimals. Number of periods is 1. Payment is 0. Present value is negative 1,000. Okay, so I'm going to find out what the future value of the $1,000 is worth 1 year from today. Let me close my parentheses. Okay. And then once I have that, remember, I'm now going to add plus, I'm going to add the $3,000. And then what happens is I do the second stage. Notice I'm in year 1 now. I'm going to say this equals future value. My rate is 0.05. My number of periods is now 4. I only have 4 years left until year 5. Payment is 0, and present value is negative 4,050. That is the negative 1,050 from the initial investment for 1 year, and then the additional $3,000 that I added to the account. I'm going to make sure that interest is compounding at the end of the year. Close my parentheses. And I get $4,922.80, which is similar to what we did previously. Okay, you could work that out on your financial calculator in 2 steps. First, the $1,000 initial payment. Second, the remaining 4 years that you're going to have to use to calculate the future value. And you should get $4,922.80.